In this video, we revisit example 2. We did all of this on Desmos.com, but I wanted to do it with pencil and paper the way we typically would, the way we traditionally would. So we're given g of x equals this rational function, and we're given an interval of x values. And the question is, does the extreme value theorem apply? And it says, if not, explain. And whether or not it applies, we're asked to find absolute and relative extrema if possible. Well, remember what the extreme value theorem says. It says if f is continuous on a closed interval from a to b, then f has an absolute max and absolute min on that interval. Well, we do have a closed interval from a to b, -2 to 4. The question is this function continuous on that interval? Well, it's not. 1 plus x cubed is equal to 0 when x is equal to -1. And you can see that by just setting that equal to 0. Subtracting 1 from both sides, and then taking the cube root. The cube root of -1 is -1. So there is an x value where this denominator is undefined. When x is -1, the denominator is 0, but the numerator is non-zero. So we're going to have a vertical asymptote there. I don't know exactly what the function looks like without using my graphing calculator, but I do know that this is a non-zero number divided by 0 at x equals -1, so that corresponds to an asymptote. Now, if I'm interested in the behavior of the function near -1, I might take the limit as x approaches -1 of that function. And you'd say, okay, well, I need to take the limit from the left and from the right. Well, the numerator approaches -1, so that is a negative. Actually, let's make sure we're approaching from the right as opposed to the, or from the left as opposed to the right. Let's approach from the left. As x approaches -1, the numerator, which is x, just approaches -1 all the time. So obviously x approaches -1 as x approaches -1 from the left. The question is, well, what happens to 1 plus x cubed as x approaches -1? This approaches 0 as x approaches -1 from the left, but we want to know, is it a tiny positive number or a tiny negative number? I know what's wrong with my handwriting right now. Well, if we are at a number, let's say negative, this is -1, negative 1.001. If I take -1.001 and I cube it, that's going to be a number it's sort of in the vicinity of that. Then we're going to add 1 to that. It's going to be negative when we add them together. So this is going to be a tiny negative number. So we have a negative number divided by a tiny negative number. So that's going to go to positive infinity as the denominator goes to 0. This is a -1 over 0 in determinate form. So we're going to get positive infinity as we approach -1 from the left. And then as we approach -1 from the right, we still have a negative number in the numerator. Our x value might be -0.999. If we have -0.999 and we cube it and then we add 1 to it, that's going to be a tiny positive number. A negative number divided by a tiny positive number is a large negative number because a negative divided by a positive is a negative. So we're going to get negative infinity there. So our function is going to approach negative infinity as we approach -1 from the right. At x equals -2, we can find the function value. Oops, not f, g. We have -2 divided by 1 plus -2 cubed. They have -2 divided by -8 plus 1, which is -7, or 2/7. Whatever that number is. Here's 1, but it's going to be relatively small. And we know that the function approaches positive infinity as we approach -1 from the left. So it's going to look like this, approximately. And then at 0, we know the function value is 0, as we have 0 divided by 1. And as we approach -1 from the right, the function goes to -infinity. And then we might be interested in what happens at x equals 4. G of 4 is 4 divided by 1 plus 4 cubed, or 4 divided by 65, which is very small. It's a little bit less than 1/16. Sorry about that. I'm doing this off the screen. But we don't really know what happens in between here. And I'm actually guessing about what happens between -2 and -1 and what happens between -1 and 0. But we might be interested in trying to find relative extrema on this interval from 0 to 4. But I guess I forgot to answer the question, does the extreme value theorem apply? No, it does not apply because the function is not continuous. On the interval that we were given anyway. Any interval that includes -1 for this particular function, extreme value does not apply. Extreme value theorem does not apply on any interval that includes -1, because we've got that infinite discontinuity there. That says either way, find the absolute and relative extrema on the interval if possible. So let's compute the derivative and set the derivative equal to 0 and find out if we've got any critical numbers on the interval of interest. So to do that, we will do the computation. Use the quotient rule. If we call the function on the bottom the low function, and this is the high function, I know that's not how you spell low and high. The mnemonic for the quotient rule is low d high minus high d low over low low. And the d is an operator, it applies to whatever's in front of it. We've got low, d high is derivative of x, which is 1, minus high, which is x, d low. The derivative of 1 plus x cubed is derivative of 0, or excuse me, derivative of 1, which is 0, plus the derivative of x cubed, which is 3x squared. And then we divide by 1 plus x cubed quantity squared, and then simplify. You've got 1 plus x cubed in the numerator, minus x times 3x squared is going to be minus 3x cubed. So that numerator simplifies to 1 minus 2x cubed divided by 1 plus x cubed quantity squared. Now, the critical points correspond to those x values that cause the derivative to either be 0 or cause the derivative to be undefined. They also have to be in the domain of the original function. Well, g prime is 0 when that fraction is 0. I don't usually show this step, but that fraction is 0 when the numerator is 0. Then we can solve for x cubed by subtracting 1 from both sides and then dividing by -2. And then to get the x by itself, we take the cube root of both sides. Remember, the cube root is the same as the 1/3 power. So x equals 1/2 raised to the 1/3. Now g prime is undefined, and that's the only x value for which the derivative is 0. G prime is undefined when 1 plus x cubed equals 0, which corresponds to x equals -1, but x equals -1 is not in the domain. So that's not a critical number. So the only critical number we have is this one. And it is a number on the interval from -2 to 4. I don't actually know what the value is, but I know it's small. We'll find the y value at that critical number. Substitute that in and simplify. And that's our G value there. So using a calculator, I found this approximation and this approximation. I just used desmos.com. So we can use those to finish our graph. When x is about 0.8, the y value is about 0.5. And I know that the point or the graph crosses through at 0, 0 here, and then it passes through here at x equals 4, and whatever that y value was. I forget what it was, but it looks like we're going to have a relative max there, just connecting those points, because it has to go through from this point to this point to this point. I think that's got to be a relative max. All we know is that it's a critical value, so it's possible that it could have just been a flat spot, a spot with a derivative of 0. But I know that it has to go from there to there to there, so I'm thinking it might be a relative max. This is a relative min, and this is a relative min, and I think that's probably a relative max, although we haven't proved it. And we know that the function doesn't have absolute maxima or minima because the function goes to positive and negative infinity on the interval of interest. So that's how we would do it without the calculator. Now we'll talk more about how we can determine algebraically, just using pencil and paper, whether or not that point corresponds to a relative max or a relative min, or just that flat spot like we talked about. But we'll save that for another video. I think that'll be about 2 lessons from now.